This is a video from the Exam 3 review in my linear algebra class. Let's take a look at 5. Let the vector space P3 have the inner product, and it's the inner product of P and Q, is the integral from -1 to 1 of P of x times Q of x dx. Find the following for P equal to 2x cubed and Q equal to 1 minus x cubed. Part A. Suppose we want the inner product of P and Q. That's the integral from -1 to 1 of 2x cubed times 1 minus x cubed dx. But that's the integral from -1 to 1 of 2x cubed minus 2x to the 6th dx. And that's 1/2 x to the 4th minus 2/7 x to the 7th evaluated from -1 to 1. If I pop 1 in for x, I get 1/2 minus 2/7. And if I pop -1 in for x, I get 1/2 plus 2/7. And, don't forget, -1 to the 7th is the same as -1, right? And then what I do is I subtract those results. The 1/2s cancel, and we're left with -2/7 minus 2/7, which is equal to -4/7. Part B. Suppose I want the distance between P and Q, but that's the norm of P minus Q. And that's the square root of the inner product of P minus Q with P minus Q. Now, don't forget, if I take P minus Q, right, this is 2x cubed minus, in parentheses, 1 minus x cubed. But that's 2x cubed minus 1 plus x cubed, right? And that's 3x cubed minus 1. So, again, the norm of P minus Q is the square root of the inner product of P minus Q and P minus Q. But that's the square root of the integral from -1 to 1 of 2x cubed minus the quantity 1 minus x cubed squared dx. But that's the square root of the integral from -1 to 1 of 3x cubed minus 1 dx. And by the way, that 3x cubed minus 1 is being squared. So let me say that again. It's the square root of the integral from -1 to 1 of 3x cubed minus 1 squared dx. Now I'm going to square that out. And when I do, I get the square root of the integral from -1 to 1 of 9x to the 6th minus 6x cubed plus 1 dx. But that's the square root of 9/7 x to the 7th minus 3/2 x to the 4th plus x evaluated from -1 to 1. Replace x with 1, and I get 9/7 minus 3/2 plus 1. And then I'm going to go minus, and then I'm going to replace x with -1 to get -9/7 minus 3/2 minus 1. And I'm going to take the square root of the whole thing. Now, notice, 3/2 are going to go away, right? And so I get the square root of 18/7 plus 14/7. Remember, 1 minus a -1 is 2, and 2 is the same as 14 divided by 7. But that's the square root of 32 over 7. And so the distance between P and Q is 4 times the square root of 2 divided by the square root of 7, which is equal to 4 square root of 14 divided by 7. So I just rationalized the denominator. Part C. Suppose I want the norm of P. That's the square root of the inner product of P and P. But that's the square root of the integral from -1 to 1 of 2x cubed times 2x cubed dx. but that's the square root of the integral from -1 to 1 of 4x to the 6th dx. But that's the square root of 4/7 x to the 7th evaluated from -1 to 1. But that's the square root of 8/7. Now remember, the square root of 8 is the square root of 4 times 2, right? Square root of 4 is 2. So this is 2 square root of 2. That's what square root of 8 is. So if I get the square root of 8 over 7, that's 2 times the square root of 2 divided by the square root of 7. But if I rationalize the denominator, I get 2 square root of 14 divided by 7. That's part C. Part D. Suppose I want the norm of Q, but that's the square root of the inner product of Q and Q. But that's the square root of the integral from -1 to 1 of 1 minus x cubed times 1 minus x cubed dx. But that's the square root of the integral from -1 to 1 of x to the 6th minus 2x cubed plus 1 dx. But that's the square root of 1/7 x to the 7th minus 1/2 x to the 4th plus x evaluated from -1 to 1. So, like before, I'm going to apply the fundamental theorem. I'm going to replace x with 1, and when I do that, I get 1/7 minus 1/2 plus 1. Then I'm going to replace x with -1, and when I do, I get -1/2, -1/7 minus 1/2 minus 1, and then I subtract the results, and then I put everything under the radical. So that's what I get down below. And the rest is just arithmetic, right? And when it's all said and done, I get 4 over the square root of 7. Let's go back. Which is equal to 4 square root of 7 divided by 7 when you rationalize the denominator. And that was 5D. Number 6. Let A equal the matrix 1, 2, -3, 5, and B equal the matrix 4, 6, 0, 8. And we want to compute the standard inner product on the set of all 2 by 2 matrices of the given matrices. Now, A transpose is the matrix 1, -3, 2, 5. B, right, is the matrix 4, 6, 0, 8. If I take A transpose B, I get the matrix 4, -18, 8, 52. The inner product of A and B is the trace, TR is trace, of A transpose B. And to get the trace of A transpose B, I add the entries along the main diagonal. And so I get 4 plus 52, and that's equal to 56. And that'll conclude this video for the Exam 3 review, and we worked problems 5 and 6. Thank you.